For centuries, humanity has looked to the skies for answers. We've asked who we are, where we came from, and whether we're alone. But as we begin to explore space with new eyes and new ambitions, a more practical question emerges. What if the future of civilization lies not on Earth, but in the asteroids? Asteroids, often seen as cosmic threats or ancient relics, are now being reimagined as celestial gold mines, sources of the raw materials that could one day support entire economies beyond Earth. In fact, asteroid mining is no longer science fiction. It's an emerging frontier in both commercial and scientific exploration. Why asteroids? These rocky bodies contain a wide array of valuable elements. Many are rich in metals like nickel, cobalt, iron, and even precious materials such as gold and platinum. Some contain water ice, which can be converted into drinking water or split into hydrogen and oxygen, key ingredients for rocket fuel. Mining Earth's crust is expensive, polluting, and increasingly limited. But the asteroid belt between Mars and Jupiter holds an estimated 700,000 quintillion worth of resources. That's more than enough to elevate every human being to billionaire status, at least on paper. More realistically, asteroid mining could drastically shift how we approach industry, energy, and survival in space. Instead of launching everything from Earth, future missions could rely on off-world resources harvested from asteroids. These rocks could fuel spacecraft, build habitats, and provide life support materials for colonies on the Moon or Mars. But how would it work? First, space agencies and companies must identify the right asteroids, those that are both rich in resources and relatively accessible. Near-Earth asteroids, NEAs, are prime targets. These are asteroids whose orbits bring them close to Earth, reducing the cost and complexity of reaching them. Next comes extraction. One proposed method is robotic mining, where autonomous spacecraft would land on an asteroid, drill into its surface, and extract materials. Another method involves heating the asteroid to release water vapor, which can be collected and stored. In some cases, the entire asteroid might be brought into lunar orbit or Earth orbit for easier processing. While we're still in the early stages, real missions have already paved the way. NASA's OSIRIS-REx collected samples from the asteroid Bennu, giving scientists critical insights into the composition of potentially miniable asteroids. Japan's Hayabusa returned samples from Ryugu. These missions mark a turning point in understanding what's possible. Private companies are also stepping into the game. Firms like Planetary Resources and Deep Space Industries have developed plans for scouting, prospecting, and eventually mining asteroids. While some early ventures have pivoted or stalled, interest in the commercial potential remains high, especially as launch costs decrease and robotic technologies improve. Asteroid mining offers more than just material wealth. It represents a strategic advantage for any nation or company that gets there first. Control over extraterrestrial resources could redefine global power structures in the 21st century, much like oil shaped the geopolitical landscape in the 20th. Of course, there are challenges. The engineering is complex. Spacecraft must operate in microgravity, with unpredictable surface conditions and harsh radiation. Communication delays make real-time remote control difficult, requiring highly autonomous systems. Then there's the legal frontier. Current international treaties like the Outer Space Treaty of 1967 prohibit nations from claiming celestial bodies. But what about private companies? The debate over ownership, regulation, and ethical use of space resources is only beginning. Environmental concerns also extend beyond Earth. While asteroid mining avoids the terrestrial damage of traditional extraction, there are worries about creating new forms of space pollution or altering orbits in ways that could inadvertently create new hazards. Despite these concerns, the momentum is growing. NASA and the European Space Agency are investing in future technologies, including in situ resource utilization, ISRU, which would allow astronauts to extract and use materials from asteroids or planetary surfaces directly, rather than relying on Earth-based supply chains. In the future, we may see mining outposts scattered across the solar system, robotic fleets hopping between asteroids, collecting ore, and delivering it to orbital factories. These factories could process the materials into parts for satellites, spacecraft, or even habitats. Eventually, this could evolve into a self-sustaining space economy, an entire industrial ecosystem operating beyond Earth's gravity well. Some visionaries go even further. They imagine using asteroid materials to construct space elevators, solar power satellites, or massive habitats like those proposed by physicist Gerard K. O'Neill, rotating space colonies that could house thousands, powered by sunlight and built from the resources of the asteroid belt. The dream of becoming a multiplanetary species is deeply tied to how well we can use the materials already available in space. If we can master asteroid mining, we unlock the potential to expand far beyond Earth, sustainably and indefinitely. At Infinity Beyond. We believe this is more than a technological challenge. It's a shift in perspective. Asteroids are no longer just relics or threats. They're keys to our survival, to our prosperity, and perhaps even to our destiny among the stars. In the next episode, we'll explore how upcoming missions and bold new ideas are shaping the next decade of asteroid exploration. Stay with us, because the future is not just written in the stars, it's mined from the rocks between them.